Hi, welcome to the discussion on this renewable energy technology. And we have discussed the wind and solar technologies in our last discussion. And today we will look at we will compare the performance of these different technologies that we have discussed, and we will compare them back to back so you can get an idea on which is better, and uh, and which has these disadvantages and which has these disadvantages, and so on, right? So first we will look at the efficiency, right? So you can see that the horizontal axis wind turbine has about 40% peak efficiency, and the vertical axis wind turbine compared to the horizontal axis ones have about around 20 to 40% efficiency, whereas the PV have a very low efficiency due to the current with the current technology, and there are research going on to advance this the efficiency of the PV system. So PV have typically 50 to 20%. So typical efficiency would be somewhere around 20%. And solar thermal, on the other hand, have a very high efficiency, like 50%. But this is mainly because the solar thermal is basically used for not for electricity but for other application, heating and so on. So the losses from converting thermal power to the electricity will not be in here. So because of that, the solar thermal have a higher efficiency, whereas the electricity generation by using the solar thermal concentrated solar systems, so they have efficiencies around again 15 to 20%, right? So concentrated solar power plant. Okay. uh, and that's how the efficiencies vary in these two technologies. And the other important factor that we need to look at is the capacity factor, right? uh, So as we have discussed earlier, the capacity factor basically measures the actual energy output of a particular power plant to the maximum possible energy output of that particular power plant. Energy output, right? So that means basically how well the power plant is running throughout the year. So this is for a given time period. Typically we do it for a year, right? So you can see the vertical axis wind turbines have a capacity factor around 20 to 30%, whereas the offshore horizontal axis wind turbines have the capacity factor of 40 to 55%. So these the capacity factors of the wind turbines, they depend on the availability of the wind, and then the wind speed and so on. In so different seasons, the availability of the wind may be different, and the directions will be different, and speed will be different. So based on that, the capacity factor the vary, and the solar PV systems have typically a capacity factor of 10 to 25%, whereas the concentrated solar power plants have 20 to 30%. And if you utilize the storage, you can go up to about 40% the capacity factor. Okay. Okay. And another important parameter is the energy yield per year. Okay. The energy yield basically discuss the total usable energy generated, right? So energy yield is basically we are talking about total usable energy generated for the yeah. And if you get the energy yield per unit area or the power density, uh, so we can discuss the energy yield for different technologies that we have discussed earlier, right? So if you get the power density of wind farms, so they experience a low power density averaging around 0.5 to 1 watts per meter square, right? And sometimes it can reach up to 1 to 3 watts per meter square, right? So if the optimal offshore conditions are met, okay? So you can see the power density is very low in this particular technology. This low density basically indicate that the larger area is required to generate a significant energy compared to solar, the other alternatives like solar, right? So you can basically imagine this without any trouble, because you know, if you get a wind turbine, it basically covers a very large area, right? So the power generated per area is uh, very small compared to the PV. So the PV you can you you can you need very small area to generate the same power as we indicated here. Okay? So for an example, if you look at the energy production of solar PV farms, so you can see that uh, the the energy yield or the power density is somewhere around 5 to 10 watts per meter square, right? So so you can see it is sometimes 10 times larger than the energy yield or the power density of the wind energy system. Okay, so uh, if you get a concentrated solar power, in the other hand, okay, uh, so it it yields the energy output very similar to the PV system, right? So you can if you compare okay, so the capacity factor is about 10 to 25% here 20 to 30%, so very close by, right? Uh, so for an example, in a concentrated solar power systems in the crescent dunes, right? So it achieves around 6 watts per meter square. So, okay. Uh, okay. So, so it achieves a similar output or the similar power density as the solar PV system. Okay. Uh, Talking about solar thermal system, basically used for heating purposes like rooftop water heaters, and they exhibit very high efficiency per unit area, right? So you have seen here the efficiency is very high, even greater than 50%, because there's no conversion to electricity here, right? But so because of that, mainly because there's no electricity generation done by these systems, there's no such numbers in like watts per meter square or power density. Okay, so they basically use the direct thermal, right, rather than creating the electricity. Okay. Uh, and so this also gives some idea about this the energy per unit area or the power density will also give an idea on how much land you need to get a certain energy output, okay, or certain power output of the system, right? So smaller the power density, you can see that you need larger area to get the required power output or the energy output, and the larger the power density or the energy yield per unit area, you can get that particular energy output from a very from a uh, you know small area, right? So it's clearly given an idea on land requirement for these different technologies. Okay. And another important parameter that we should look at when we compare the renewable energy generation is the load matching capability. How well these systems can match the load and produce the requirement of the load, right? So if you compare these different technologies, so for an example, if you look at the wind energy, uh, so the wind energy have intermittent, very inherent intermittent nature, right? So that means it is varying, widely due to various factors. So wind speed varies, the direction of the wind varies, it varies due to the temperature and the temperature changes. So you know that wind is basically blows due to temperature changes in 2 points, right? So so this can be due to various factors. So because of that, the wind speed and the wind direction can vary very rapidly. So that's why we call it an intermittent energy source, right? So this wind is a intermittent energy source, and this intermittent nature of the wind energy. Uh, so uh, it makes it less reliable and very difficult to integrate with the loads directly, right? So you know that the due to the changes in the wind speed, the energy or the generation will also vary, right? So wind speed and direction is varying, so which in turn varies the generation. So then we need to couple this back to the grid. So we have to facilitate these changes. So the grid would like to see the constant frequency 50 hertz or 60 hertz connecting to the system, right? And then with this variation, you have to have uh, a separate control system to manage the frequency and amount of generation that is dumping into system. Because if you get the grid, so you have energy coming into the grid from various power plants, right? Or the say like wind power plants, the hydro power plants, coal power plants, and so on. And the other hand, you have demand from different loads, right? So this the power demand and the power input to the system has to be matched, right, closely to maintain the frequency of the system. Okay. So if the power generation of the wind is varying very rapidly time to time, so it is very difficult to maintain the system frequency and very difficult to match the load capabilities as well, right? So uh, due to this varying power, so you have to have some sort of mechanism to facilitate that, right? Sometimes you can use the energy storage, and then from the storage you can dump to the grid, so you can regulate the energy you dump into the grid more effectively. But the cost wise, that would be a very high solution, high cost solution. And if you look at the solar, right? So it has some sort of a predictable daily production profile. So you know, if you get the solar, you have a high solar during the midday and low during the early morning and the night, right? So you know this profile is there, but this profile can change due to various factors like cloud coverages, right? and whether it's a rainy day, sunny day, basically defined by the cloud coverage, and also you have the moving cloud as well, right? So, so when the clouds are moving, right? So this can go down and come back and so on. So there are certain intermittent nature associated with the PV generation as well, but with the certain with the environmental data, you can predict the daily production or availability of the solar irradiation, and then you can predict the daily power generation. So it's not that intermittent as the wind energy, but it also have a certain intermittent nature. So sometimes that can also affect, right? So for an example, not recently, yeah, maybe yeah, one couple of months back or somewhere, right? So I have visited a factory, right? So they are producing the clouds, and they wanted to put a PV system to for their power requirement, right? So one of the major concerns they have is that they have very sensitive equipment. If there is a sudden power drop due to the cloud coverage like that, that could stop or kind of stop this production cycle, which will be eventually mapped into a considerable cost. you know the slowing the production cycle, or cutting down the production cycle for even for 1 minute or so, or even less than 1 minute, eventually map to hundreds and thousands of dollars, right? So they have this concern. So how well the energy generation by the PV system can match what the load requirement. Okay. And you also know that since in the early morning and the night there's no solar available, so you need to if you have a uh, off-grid system, right? Okay, disconnected from the grid, then you need to have a certain energy storage in order to produce the demand requirement at the night and the uh, early morning. So solar is capable of matching the load demand in the daytime, but in the night time and the early morning, if you want to match the demand purely by solar, then you have to have a energy storage, which is also again be a little bit of costly solution. Okay. Uh, okay. So if you look at solar thermal systems like the hot water systems, you know that they have this specifically made tank system, so which can actually store the hot water, right? And then you can use it when needed. Sometimes you can keep the temperature of the water for maybe like 1 day or so. So without any issue, you can supply the demand or the load requirement. Okay. Uh, okay. And if you get the concentrated solar power plant, so if you just have the concentrated solar power system, then that may not be that good. Again, that will have the same problem as the PV system. How we can match the day, early morning and the night demand. But if you have a concentrated solar power system with the thermal storage, then you can it will become very high. The efficiency will increase, and it can also match the nighttime load, right? Because you have this thermal storage system, right? Like in the thermal energy. because that technology have been developed, so we can easily use them rather than storing the electrical energy, which is higher costly in the batteries and things like that. You can store the thermal or the heated water also, so in the thermal storage. So that will be less costly and highly effective, right? Uh, and then when you have the thermal storage, it can be dispatched on demand, right? So even after the sunset, and they can provide they can match the load without any issue. Okay? So if you compare these energy sources in terms of meeting energy demand effectively, you can see that the concentrated solar power with the thermal storage surpass all the other solar technologies like solar PV and solar thermal, right? And okay, and also it also exceeds the load matching capability of the wind energy system, right? Okay, and you have also seen that the solar PV, it's obvious that the solar PV system without storage will fall short at night, right? And so on. Okay. So different technologies have different load matching capabilities, right? So the intermittent nature of the wind and solar, we have to incorporate in here when we are looking at whether we can match the loads and how well we can match the load. And again, as I said, about that factory, you can also see that eventually everything will converted to the money value, right? So I don't know, like in rupees or in dollars, right? So you have to look at that aspect as well. Okay, so if you can't match the demand, what would be the losses associated in the money value, like right? So then you have to find the solution that match probably the money you spend for the energy storage would have been worth when you look at the losses in money value. So you have to do that and compare them to see how well we can match the load and at what cost, and whether that cost is reasonable to bear or not. Okay. We can also compare when comparing these different technology, we can look at the environmental impact as well, right? Uh, so there are the various aspects that we can look at. The one is the greenhouse emission, right? So you know that the renewable energies have very less greenhouse emissions. For an example, renewable energy sources like wind have 11 grams of CO2 per kilowatt hour generation, and solar PV has about 41 grams CO2 per kilowatt hour, because this is uh, uh, there is certain CO2 emission during the production as well, right? So, so this is little high compared to the wind because of that. When you are producing the solar cells, so that contribute to the greenhouse emission. So there are certain processes that contribute to the greenhouse emission. So because of that, this number is little higher than the wind, but you can see that they are significantly less than the greenhouse gas emission of a coal power plant, like which eventually, in the coal, you get like 820 grams per gram CO2 per kilowatt hour, right? So very high compared to the PV systems and the wind energy system, right? And the air quality, right? So you know that the wind and solar energy system produce no air pollution, right? So no air quality, no CO2 during the operation. no other gases during the operation. So there is no air pollution in this compared to the fossil fuel based power plants, which are basically emitting gases like sulfur oxide and NO2 and so on. Right? So okay. uh, okay. But on the other hand, the wind energy system, they can yield to certain other issues like the turbine noises, right? And so the birds and bats mortalities, it basically block the pathways of birds and bats, and due to the nature of the rotation of the wind speed with turbines, sometimes the bird can't predict at what time I should pass this turbine blade, right? So they hit on the blades, and sometimes they die. Okay? So and also there is certain the block in the wind speed as well. So because that wind energy is used by this turbine, so the wind speed at the other side will be lower compared to the normal wind speed in the system. Okay. And also there's one thing that the shadowing effect. So if you live nearby a wind turbine, you will be experienced that if you have a house somewhere here, when the blades rotate, you will experience the shadowing, right? And then it comes back and so on, right? So because of that, typically there should be a certain area that is you know uh, yield for this uh, between the turbines and the typical residential area. So you have to have certain land free because of this purpose. Okay. Uh, so otherwise the people will you know uh, experience these effects, and sometimes that can yield to various other uh, illnesses like nausea and so on. Okay. Uh, okay. But these issues can be mitigated from careful planning. As I said, if you carefully plan, okay, how much land I should eliminate between the wind turbines and the residential area. So you can also reduce the sounds going into the residential area, as well as you can mitigate the shadowing effect. And then when you design the turbine cover, you can make it soundproof, so you can reduce the sound coming from the turbine to the other sides and so on, right? So various the techniques can be used to mitigate these kind of impact. Okay. Similarly, like the wind turbines, solar and the concentrated solar power can also affect the land use and also the habitat, right? So you need again very large land area for this, laying out the solar panels and putting the solar towers and so on, right? So you when you are coming to the site selection, you have to be very responsible. So you have to look at you have to account all the damages, including the damages done to the livestock and their habitats and so on. uh, so after doing that, you can carefully select the land for these kind of power plants. So if you do that, this kind of impact will be minimized, right? Okay. If you look at the water usage, the concentrated solar power plants, so they can consume significant water for cooling, right? With process challenge in the regions where you don't have that much of water, right? Uh, but there are different technologies available like dry cooling to as an alternative to these issues. Okay. Uh, Whereas the PV and wind energy use the minimal water, okay, mostly for cleaning purpose. So you don't need much of the water. So you can even put them in sometimes desert, right? So you know that in Africa you have a lot of wind power plants. Sorry, the lot of PV power plants, and then they have put high voltage DC lines from Africa to Europe, so they can transmit their energy generated from these African countries to the Europe, right? So so there are projects like that. So you don't need much of the water, but you have to clean the PV panels time to time. So that's where you need water, right? And when it comes to how we can recycle, because we are talking, how we can recycle. Uh, the recycling the wind turbine blades remaining a challenge, okay, due to the fiberglass composition of these wind turbines. Okay, uh, okay, and but the steel towers and the copper wiring, so they are easily recycled, right? If you look at the PV panels, they have also certain issues when it comes to recycling. Okay? It also have some recycling component, but in the recycling industry for this material is still to be developed. So the materials used to create the solar cells. So how we can recycle them, and there are technology available, but the industries for this purpose has to be still developed. Okay. Uh, the other aspects that you have to see, other than the technology aspect, is the financial aspect, and so this slide compares and analyzes the capital cost of and the uh, levelized cost of energy for different energy technologies. Right? So if you look at the capital cost, the onshore wind turbines, wind farms have like $1.3 million per megawatt, right? Whereas the offshore have about $3 to $5 million per megawatt, and the utility scale PV systems have the capital cost will be around $0.8 to $1 million per megawatt, whereas CSP have a little high capital cost, $4 to $5 million per megawatt, and solar thermal systems have very value somewhere like $500 to $1,000 per kilowatt thermal, right? Because we are talking about the thermal energy here, not the electrical energy here. Okay, and if you look at the levelized cost of energy, so the onshore wind turbines have around 0.04 to 0.05 per kilowatt hour, and the utility PV have $0.05 to 0.06 kilowatt hours. So you can compare different technologies by looking at these numbers. So whereas the CSP have 0.1 to 0.18 kilowatt hour, right? And if you look at the Sri Lanka's wind power tenders, so they expected to be somewhere around $0.05 or less. Okay. So other important parameter when it comes to the renewable energy projects are the payback periods and the return on investment, right? If you look at the payback periods and return on investment for the wind farms, so they typically see the financial payback period ranging from 7 to 12 years, right? And the return on investment is usually in the low teens, like 13, 14, something like that percentage, right? So which can vary depending on the availability of the energy resources and the financing structure, right? If you look at the PV farms on the other hand, so they have the payback period approximately 5 to 10 years, right? And the rooftop solar PV system may have even shorter payback period, somewhere around 4 to 7 years, okay, specifically when subsidized by the government and so on, okay. And and the return on investment could be 10 to 20% annually, because due to the available based on the available energy yield, right? And if you look at the concentrated solar power plant, so you can see the payback period is between 12 to 20 years, right? Because it has certain high capital cost, and so the without any incentives, the return on investment might be single digit, right? Which has okay. And then the solar thermal systems, the payback period is around 3 to 6 years, and return on investment is approximately around 15% or more, right? So you can see so because of this, it seems like the solar thermal is very very sound investment for households looking for saving electricity or LP gas bill. So if you are using electricity or gas for hot water, so converting that to the solar thermal systems would be more effective, right? Uh, and If you look at the operating cost, because for the to calculating the payback period and the return on investment, so this also matters, right? The for the operating cost, the PV have the lowest operating cost, right? Which is estimated about 0.005 to 0.01 per kilowatt hour, right? So that makes the solar PV systems financially attractive, though the initial cost may be high, the capital cost may be high, but the operation and maintenance cost is very low in the solar PV system, right? So if you look at the same in the wind, it is somewhere around $0.1 to $0.202 per kilowatt hour, right? And This is for so if you go for offshore wind turbines, operation and maintenance cost be even greater due to the challenging the marine conditions, right? Uh, so the operation and maintenance cost in the concentrated solar power plants, it ranges from 0.02 to 0.04 kilowatt hour. Okay. So okay. And there are various other external factors that influence the financial cost, right? Such as interest rate, significant and then significant of the significant impact. So this can have a very significant impact on the project, and then there are could be some political reasons as well, right? Uh, so this payback period and return on investments also vary with those kind of things, like whether there are any incentives associated with the project, and whether there are financial supports or the government influences, and all those things matter when actually calculating the payback period and the return on investment. Okay. Okay, so let's look at some strengths, weaknesses, and cost analysis of different the technologies, right? Uh, so if you compare the horizontal versus vertical axis wind turbines, the horizontal axis offer high efficiency in converting wind energy to the electricity is about 30 to 40%, right? And so the vertical axis have lower performance, and when it comes to the large scale, it's not actually competitive for the horizontal axis wind turbine. So that's why you don't see the vertical axis wind turbines much in the picture, right? But if you are talking about the distributed energy resources or small scale energy generation, you can go for vertical axis wind turbine. Okay. And if you compare the solar PV and the solar thermal, the solar PV is widely scalable and has low levelized cost of energy, right? And then the solar thermal is very efficient for heating application, and has quick payback period as well, right? But it's not used for electricity generation. But you can use them to save electricity. For example, if you use the solar thermal for water heating and heating application, so you can save the electrical energy that you spend for that kind of application, right? And the wind and the PV, they both faces the intermittency challenges, right? But the solar thermal may not face that problem because you have the thermal storage technology. Right? And if you compare two different technologies that produce electricity out of the solar, the concentrated solar power plants versus the solar PV. Okay, so the concentrated solar power plants are dispatchable due to thermal storage. Okay, and it is ideal for delivering power even after the sunset. Right? And the PV is the fastest growing power source, and it is currently cheap, and you have seen that the operation and maintenance cost of the PV is also very cheap. Right? Okay. And the future of the concentrated solar power plant will strongly depend on the storage technology and the advancement of these storage technology. Okay. If you look at the cost of wind and the solar, so wind and the solar PV are the cheapest option for new power generation globally, right? And concentrated solar power costs more, okay, compared to the wind and the solar PV, but it offers the value of storage, right? So easy storage compared to the wind and solar, because wind and solar, if you're looking for the storage, you have to go for battery storage, or with the modern technology you can go for the hydrogen storage and the fuel cells as well, but this technology is still developing and very very costly at the moment, right? And if you look at the environmental impact, the wind has minimal land footprint, but potentially wildlife concerns are there, because it says land footprint because you have this tower and certain surrounding land, and this is in way half, so you can do something in this land area, and there's a gaps between the wind turbines as well, right? So because of that, you can utilize this land area for some other purpose. Okay? Whereas the solar PV, if you put the PV power plants, then you will utilize this land most of the land for the PV panels, but there are research and there are new technologies available, like can we cultivate or can we do agriculture with the PV power plant. So there's a area called agrophotovoltaic, right, where the researchers are looking for doing the agriculture effectively, cultivating certain foods and so on effectively while you generating the electricity from the solar power plant. So in this case, the solar cells are made a little bit differently, so they keep certain gaps between the cells, so the certain sunlight can pass through to the vegetation underneath it, right? So something like that. Or you can even use the transparent solar power plant or PV, right? So these kind of technologies being investigated. Okay? Uh, So if you look at the energy output and the reliability, the 100 megawatt wind farm yields to 306 gigawatt hour per year, and 100 megawatt PV farm yield 175 gigawatt hours per year, right? So you can see the wind produce more energy output compared to the PV power plant with the same power rating, right? And these slides basically summarize all the performance evaluations that we have discussed so far. So this discuss about the efficiencies, the capacity factors, the energy yield. So you can see the numbers and you can do the comparison by yourself. Right? So I'm not going to go through all the numbers and so on, but we have already discussed these things. This slide basically summarize all the things, and this also summarize the other factors like the capital cost, payback period, operational and maintenance cost, and the return on investment for different PV technologies and the wind technology. Okay, so that's all I wanted to discuss under the PV and wind technologies and the comparison between those technologies. So in the next discussion, we will look at the other different type of technologies, such as uh, the what do you call this? The other wind, energy resources like the biomass, hydro, and marine energy and geothermal. So we will discuss all of them together, right? I have put more focused on wind and PV because this is very widely used technology. But uh, with the PV and the wind, depending on the availability, and the people also use the various other technologies like biomass, hydro, basically focusing on mini hydro, and the main marine energy, which is the energy that we captured from the sea, and then the geothermal energy, the thermal energy that we capture uh, from the earth itself, right? So we will discuss that in our next class. Thank you.